Right. Which 5 components can be used to define a problem? Anything?
I have no idea. This is my first class, so I'm like, yeah.
All right. Anyone? Okay. All right. So rather let us do this, and then we'll come back to this question. Okay. Right.
Could I might ask?
Yeah.
How far are we, or how far are you guys already with all the classes? Have you like completed half the semester's work already, or?
We hadn't really started.
Okay.
Yeah, we hadn't really started. Let me see from my notes. Aim of this one. Just want to bring the last slides. All right. So we done. Right. So we discussed task environment, what it was, this we did not do. Okay, where is this? Lesson 1, lesson 3. Right. If you want to define a problem, right, just while I'm looking at this, and see if anyone remembers, you need a defined starting state, right? You need to know where exactly it is, what is the starting point of that problem, right? You need to understand where you are. Then from once you know you have the start state, you need to understand what actions can you take whilst you are in there, right? Any of that sounds familiar? No?
Yes.
Yes.
Right. And then after that, you need a. Come on, guys. We done this. I think. Yeah, I remember we did this. And then yeah.
Yeah, and then after that, we need a description of what each action does.
What is that called? There's a term that is used to define that.
Yeah, it's been a long since we've attended this class. Yeah.
Yeah. All right. It's been long since I last taught as well. It's evident. It should be here. Right, class 3. Right. Cool. So it's here. You. There you go. Right. So this is the slide I was looking for. So we've got goal formulation, right? Based on the current situation in the agent's performance, it is the first step to solving a problem. So we are saying if you are in a given scenario, goal formulation is the first step to solving a problem. What do you mean? You have a problem. We have to think of what, for it to be a problem, we have to, there's need for us to know where we are going or what is the ideal, right? Think of any problem in this world. For it to be called a problem, it's because there's a norm that it's supposed to align with that it is not aligning with, so that's why it is a problem itself, right? So problem formulation is the process of deciding what actions and states to consider given a goal. We know we want to get to X, right? We are at O. How do we get to this goal? So that's problem formulation. We're not formulating the problem. And then the process of looking for these actions, right, is called searching, which we're going to look at in the next class. And then a search algorithm will take, it's a black box that takes in a problem and gives out a solution, right? So I don't know if you remember those in the magazines back then. There used to be that section that used to have puzzles and games. There was this one where you need to find, with a lot of pathways, where you need to find, they will give you the opening, right? And then they would give you the end, and they want you to trace the pathway that leads to the outlet, right? So it's a black box that you give it a problem, it will give you a solution, right? Then this is important. We discuss this when we're talking of an environment. We say that environment is what? When it cannot change whilst the agent is deliberating. What did we say that is? What process or what aspect of the environment is that? It does not change, or it does not, the environment does not change when it takes in while it's deliberating, right? So if the environment is static or dynamic, right? So while the agent is executing, it will ignore all precepts, right? So it doesn't really happen to us as human beings, but it's something that you would maybe like to use when you're abstracting for a machine, right? So what does it mean ignoring the precepts? I'm saying, let's say you put your hand on the stove, right? Ignoring the precepts while you're making a decision is you putting the hands for 30 milliseconds more while you are deciding on what to do, right? Or if you have played boxing or something like that, right? You have to be in constant, you have to be in touch with the precepts so that you do multiple maneuvers at the same time. You're thinking of attacking, but you have to defend. And so you're saying, while you're thinking of attacking, you cannot anticipate anything else that's coming your way. And then that's, well, a quick way to lose a boxing match. But then in this particular case, we're saying our agents will ignore precepts or inputs whilst it's deliberating, right? So computers, if you remember, maybe you've come across it with Excel. If you open a very large Excel file, right, that guy will start appearing, going like this. It's not going to take any inputs whilst it's deliberating on an action to take, right? So that's what generally our agents are going to be doing, right? And then a problem can be defined formally by 5 components: the initial state, a description of possible actions, a description of what each action, right? So that is the transition model. So I think it's Jalapedi, you're mentioning this, right? Is the transition model. That is what I was looking for, right? The goal test and the path cost function. So those are the 5 components of a problem. Right? Does that make sense?
Yes, it does. Thanks.
Right. So to answer this, that is how you would answer this one. So you have got opening state, actions, transition model, other one is what? Goal formulation. What is it? The other one is goal test.
Goal test? Yeah.
Goal test and path cost.
Path cost.
Right. Goal test and path cost function. Path cost function. Yeah. So that is the 5 components of a problem. So you are simply listing. So this one says list. Right. So there is list, there is describe, and there is explain. I hope you understand. So the difference between the 3. Simply listing, you're saying just write 1, 2, 3, 4, 5. Explaining, now you have to explain what a transition model is. You have to explain what the goal test is, the path cost function is. Describing is telling what it is, right? If someone asks you to describe your room, you're saying there's a shoe on the floor, there's an unmade bed, there's a stuff like that. You're describing, you're saying what you see, what it is, right? Explaining is then saying, yeah, the shoe is on the floor because I never got time to pick it after I removed it. That's now explaining, right? But if someone says list the things in your room, you are simply giving an account of what is there, right? Then here they say differentiate between a safe space and the goal space. So we're here to touch this. Right, we're here to touch this. I wanted us to look at a problem formulation question. An example that we can use. Normally they give, looks like we're lucky this year. All right, there we go. Question 4. So let's use question 4 as our example for today. Question 4. Right. So question 4 talks about 3 hikers, Moses, Elizabeth, and Wayne. They've just descended down a valley to find themselves confronted by a river they cannot get across. After walking downstream for a while, they find 2 young boys with a boat. They ask them if they would help them get across the river. The boys agree, but inform the hikers that since their boat is small, it can only hold 2 boys or one of the hikers at a time. Right? We can assume that everyone knows how to row a boat. Right? So what are the parameters here? It can only hold 2 boys or one of the hikers at a time. Right? we can assume that everyone knows how to row. Define the state. First of all, is it possible for all these people to cross? What do you think about this question?
It should be. There's just some maths to. Are they basically going back and forth, right? But all of them have to be on the other side, or do they cross
Yeah.
it one at a time? It should be possible. You just need to do the correct combination between who is going and who is staying.
Is there any constraint that cannot possibly be? I'm seeing a constraint here. Is there any constraint that you're seeing that might not allow all of them to cross?
Okay, let me just see.
Right. The boys
Oh,
agree, but inform the hikers that since their boat is so small, it can only hold only 2 of the boys or 1 of the hikers at a time.
Yes, so if one of the hikers goes across, the constraint is he can't come back to pick up the boys. Because if he rows back, he has to get out again.
Right. So there's no one who's bringing back the boat.
So the only way for them all to get across is one boy has to go, 2 boys have to go across, 1 boy has to come back, the hiker has to go across, the boy has to climb into the boat, go across, pick up the other boy and come back to the hiker.
Right, it's 3 hikers.
Oh, sorry. There's 3 hikers. Okay.
Mm-hmm.
Then the 2 boys have to cross. The hiker has to. The 1 boy has to come back. The 1 hiker has to. Oh, holy crap! Now the 1 hiker has to cross. The 1 boy has to row back. Then the 2 boys have to row back again. 1 boy has to go back, pick up another hiker. Basically, the cycle repeats until the other boy has to go fetch the other boy on the side and come back.
Yeah. The other guys, are you following?
Yeah, yes. That means they're gonna
I love this
do that
question.
until all of it.
Yeah. So how do they cross? We're saying you want boy, right?
Yes.
So that's number 1. Number 2, then you put
Boy.
boy coming back, right?
Yes.
Then number 3, it will be say Moses going there.
Boy
Then
coming back.
right, number 4, it will be boy coming back. Number 5, it will be
2 boys going back.
2 boys going there. Number 6, it will be boy coming back.
Yes.
Number 7, it will be, what's his name? What's the other guy's name? Elizabeth and 1. Elizabeth. Yes. And then number 8, it will be boy. Number 9, it will be boy. Right? Then number 10, it will be boy. Number 11, it then becomes
the next hiker.
1, right? And then number 12, it will be
boy first.
Boy. Then number
13,
boy. Right. This step is not really necessary because the boys were not, we don't know what the boys were doing. What we know is the
hikers want to go across.
The hikers wanted to cross. Right. So that is sort of our solution there. Right. This is the easy part. How do we represent that mathematically? Right. So to represent also define a state using a mathematical notation. Pictures or any form of graphical notation will not be accepted. Right? So you cannot go and say, discuss the appropriateness of your choice and provide an example to show that it will be suitable to be employed during the search. Right. So what is a state? What represents a state? What
Each time they cross is a state.
Right?
Isn't it? Each time they cross is
Is the transition the cross, or what can we use to define the state?
I think there's two stages, where they started and then where they going, the other side.
Right. So we can use the two crossing sides, right? So why would you go for that? Because they are fixed. So the transition has got a lot of variables. Look at the transition. In between, there's a lot of variables. So would have multiple states, right? A lot of states. But if you go to fixed states, we can look at the river and the bank side of the river. So on the two sides of the river, right? So initially, we are having all the people on the other on this side, right?
Yeah.
Right. So order is not important, really. Order is not important, right? So we are going to have what do you call it? Moses Elizabeth 1. So we have B1, B2, Moses Elizabeth 1.
Yes.
Right? And initially here there'll be no one. Right. So what we can do is we can have a set, right? A state will be represented, say state S naught. What can we use to represent this set? Sorry, a state. What can we use?
No.
Right. So this is one side, this is one side. So this is going to be curly brackets to present the order. So we're going to have a list here, and we have a list there. Right. Is this fine? Remember, mathematically brackets have got meanings. Right? What would be the difference between these brackets, these brackets, these brackets in math?
That I don't know.
I think the first one is set.
Yeah, it's set.
The first
The
one is
first one is set, yeah.
The second one?
The range. Or...
The list. The last one? It's a tuple, right? So I think you've done some coding at some point, C, right? You see this, you cannot use brackets anyhow, just how we like.
But they never explained this to us in programming. They were just like using them, so we just use them.
No, it's assumed knowledge. Remember, in COS3501, this is one of the very first things that we look at.
In C++1.
No, COS1501.
That's Python.
No, that's your introduction to computer science, like you did it long time ago.
That's long.
So the bracket, each and every bracket has got a meaning, right? And that meaning is there to stay. That's why when you use, if you want to, if you want to do a 4 and then you use this bracket, it's not gonna work. Right. So it's because these brackets have got meanings, mathematically speaking. So,
but I didn't know that, to be honest. They never taught us that. I kid you not. They were like maybe brief, just read over it, but I never knew that the brackets had physical meaning. I was just like, okay, when I do a for loop and I want to do stuff, I just put that bracket. If I want to do this, I just put that bracket. I didn't know that they had actual meanings.
Yeah.
Yeah, really. I learned something today.
Yeah. Now
I
I know.
just
Yeah,
grab
but
them. I know that they may be a for loop. You need to use this one. But
Makes a
I'm
lot
in
more
agreement
sense.
with Guda. I know they do have a meaning. They are not just there for fun. So yeah.
So just go and have a look at it after this class, and then it will make more sense what we're about to do now. Because this question is very tricky, especially if you want to, because for example, a list, if I have a list, right? A list is a list, doesn't need to be ordered, right? It doesn't need to be ordered, or it can be an ordered list, right? So in fact, a list I can index. If I use these brackets, I can index, correct?
Yes.
You can index. So position 1, position 2, position 3, position 4, right? Then you can say, you can go and say at position 2 there is, so forth, right? If you have a set, there's no indexing. If you have a set, there's no indexing. You just have 0, you have 1, it's elements of a set, right? Then if you have these brackets, right? 0, 1, 2. So this is more or less, if you have 0, 1, right? It's a tuple. It takes 2 inputs, right? So here, this bracket, it takes 2 inputs. So like coordinates, if x, y, right? If you have 1, 2 on a Cartesian plane, you're going to have 1 here and 2 up, and then this will be the coordinate, right? So here we're saying these you can take into inputs, and then if you have a z plane, say for example a z plane, right? Then you'd have maybe 2 as well at this point. So you're now looking for you're not looking for my drawing is not the best, but yeah, hope you get what I'm saying. So this is a tuple. We are saying 1 and 2 go together. It's an ordered pair. It's this input corresponds to that input, if I should say. Does it make sense? I challenge you to go and have a look at it, and then the meaning of these brackets and stuff like that. So to answer this question though, right, is order important?
No, it's not in terms of which hike has to be, as long as they all get to the other side.
Right.
There's no order needed.
So we can use a set inside.
Okay.
I want on one side to be these elements, on the other side to be these elements.
Okay.
Right. So let's now attempt to discuss or define a state using the mathematical notation. Right. So so state Si is equal to a tuple, right, or sets, right, A, B, C, D, E, right. So state Si, so we're now explaining that or describing the set and what it will contain. State Si is a tuple representing the two sides of the river, right?
Mm-hmm.
The two sides of the river. The two sides of the river, right? It will indicate it will indicate which elements, or in this case, which people are on which side of the river. Which side of the river? Right. Okay. What about the bot? Is the bot a part of the element? Because remember, we want a state to give us a full representation of the problem. Right. So if you look at one state, you're supposed to know the state or what the problem is about, more or less.
Okay. The boat should be part of the set as well, because the position of the boat matters.
Right. So the boat is part of the is part of the elements. Right. Right. Then we want to define it according to this. The symbols to be used. Symbols to be used will be, so now we're providing a key. There's one, so that will be W. There's Elizabeth, that would be E. There's what is it, Michelle?
It's one, if I'm correct.
Moses.
Oh.
Moses. M. Boy 1. B1. Boy 2. B2. And then board, we'll call it what, B3 or what? Can call it anything really, it's our key.
Yeah, I call it T for transport.
Right. Let's call it T for argument's sake. Right. So an example of a state is in, so you can have the E, B, B1, T, and then we have, so many elements, 1, 2, 3, 4, 5, 6. So we're going to have here M and 1 and B2 this side. Like that.
Okay. Do you have to now, I see this is now only an example. So do you have to write down every single possible state
No.
as the answer? Okay.
No. You are giving an example, you are giving a mathematical representation.
Okay, I'm with you.
Right. So here they haven't even asked you to give the initial state or whatever the case. They're saying, how would you define a state? Because remember, you're going to use this model to define all the states that you're going to refer.
Okay.
Any questions there?
Oh, this one is a part of question 1.
Sorry?
I mean, it's a question 1.
So this is, yes, so this is 3.1.
3.1.
Mathematical notation.
Normally it's 3 to 5 marks.
Okay.
Right. Then they say define the start state and go states using your representation. So start state is not, we can then say it is a tuple where everything is on one side, right? So you're going to have B1, B2, T, M, E, W, and nothing here. So this is the initial state. Goal state is equals to, oopsie, and then everyone will be that side. B2, T, so definition of the goal state. Here we need to be clear again, because the goal is for the hikers to cross.
Yeah, so it actually can end as soon as the 3 hikers is across, because what the boys do doesn't matter, right?
Yeah, as soon as we have this scenario, where is it? As soon as we have this scenario, M, E, 1, like that. Then
with a T.
Sorry?
By that time, the T will be also there.
Right. So the goal is for them to cross, but for the purpose of this, let's get everyone across. Right? Let's get everyone across. Right. So I want to see what their response would be. So let's get everyone across. So we're also going to put T, B1 and B2. Right. But to be more accurate, the goal is for these 3 hikers to cross. So unless the boys were also planning on crossing. Right. That was left out. Right. So this is the initial state, and this is the end state, goal state. Are we in agreement yet?
Yes.
I'm with you.
Right. Right. Define an appropriate cost function or functions for this problem. Right. What would be an appropriate cost function?
I'm not sure what a cost function is. So
Right. So, like for example, let's talk of petrol. Right. It's a nice subject to be talking about these days.
Just hurt me.
If this boat was using petrol,
okay,
what would be the cost function?
Yeah, the trips, there will be many trips.
So the trip, or each trip will be a cost on its own, right?
Yes.
It doesn't really matter who is in it or not. So each trip is a cost. Right. Another way to look at it is to say there's a weight cost associated with this, because it can take only 2 boys or 1 adult.
Okay.
Right. So there's a trips part, then there's the weight cost part. Make sense?
Yes. With you there.
Right. So define an appropriate cost function. So we can say there's the distance cost, right? Distance, we can say, you can call it X, right? Which is each time for each successful river crossing. Successful river crossing. right? Then we give the weight, right? We can call it B1, B2 is equals to Y, right? And then W, E, M will be equal to 2Y.
2y. Okay.
Right. So this will be the distance cost and the weight cost.
There's no time in this particular example. There is no cost function for time.
There wasn't really, they didn't say if the time is a factor, they could have said they have to cross within 5 minutes, or it was not really stated, but of the measurables that we can measure, there is a distance. So we can measure the efficiency of this crossing. For example, if there was a different boat, we can measure efficiency, and we can try and improve this solving technique, right? Maybe this one we have one solution, but other problems we have multiple solutions. And then when you're searching for the problem, you now want to consider the cost functions for this, to say, okay, which one when can I cross in the least possible, using the least possible distance. Sometimes time might be a factor if the time cost is given, or we know the time cost. Yeah, it's fine. So if you're driving from here to Durban, then speed is time. Yeah, time is there's distance, then there's time. Right? But in this particular case, time was not said to be an issue.
100%.
Right. Then provide a formal definition of a valid action for this problem. You do not need to provide a formal definition for the operation of the function. Discuss the operation of the function and provide an example to illustrate this. So you're providing a formal definition. Let me just take this off.
Hello.
Yeah.
Hi, how are you?
Hey, I'm okay.
Right. Sorry about that. So provide a formal definition of a valid action function for this problem. So we want a valid action. What would be an action? An action, we're saying, if you are in, say, state S naught, right? We say you've got B1, B2, T, M, E, W. Right. What actions can you do? Applicable actions
is either BB or one adult.
Applicable actions, here you're going to have BB,
T or M or
E, W.
W,
So
sorry.
we can add T here. We can see BBT, MT, ET, WT. Right. So if we do this, these are the applicable actions at any given time. Or we can have B1T or B2T.
Okay.
Right. So these are the actions. So we can just write it. The actions, it's just a formal set. So action action is defined as, right, the occupants of the boat crossing the river. Right. So and then it is a set action S. It is a set of it is a set of, you're saying it's BBT, MT, ET, WT, B1T, B2T. Okay, like that. So these are the valid actions for this problem. So you don't need to operation to give a formal definition of the operation, right? Then you want to discuss the operation of the function and provide an example to illustrate. Right? So for example, if we are in S naught, right? So the result, if you are in S naught and you apply a particular action, say B1, B2T, right? You're going to end up in S1, which is going to be equal to W, E, M, B1, B2, T. Like that. So this is the, do you see what I done here?
Yes, is that the mathematical formula then?
So yeah, that's the sort of the transition model. We're now saying if you apply this action, if you apply this action on this particular state, you end up on this state.
Okay, okay, I'm with you.
Right.
Yeah, I think it does make sense. If
Okay.
you say it's transition model, because it's a description of what each action does.
Yes. On a particular state.
Yes.
So if you apply this action on a different state, if you apply it on S1, it means they're going to move this way.
Okay.
Okay.
No, get it. Thank you.
All right. So
Maybe can you just explain that part again? I'm trying to catch up. Sorry.
which part? Say.
The result one and SO.
Right. They say discuss the operation of the function and provide an example to illustrate its case. So we're saying apply the use. Show me the actions in use. Get it? Show me an example of you using the action. Right. So we're saying we have discussed the actions, right? We have described the actions. We know what our actions are, right? These symbols have already been defined, right? So we're saying this is how it is going to work. So for example, you are in the initial state, which you have defined, a state we've defined, and you pick this action, you are going to end up in action in a different state, which you're going to call S1, which will be defined by these parameters.
S1 is one of the state, the possible state.
Yes, if the boy and the boy cross the river, then that is a new state that we have.
Oh.
So the initial one that we done, right? The initial now it's going to be, it will then turn long. We have S naught, which we say is equals to B1, B2, T, W, E, M. right? Like that. And then how many possible actions are here? Right, we can have B1, B2, T. We can have B1, T. We can have B2, T. We can have WT. We can have ET. And we can have MT. Right. So these two don't really give us much, because once you go, he's going to have to come back on this particular instance, right? So if I take any one of these, for me, I chose I took this one, right? So it led me to S1, which is equal to W, E, M, and then we're going to have B1, B2, T. Sorry. Right, like this. You can do that to any of these other branches. Maybe let's call this S2. It will be equal to, you're going to have the boys, W is gone, sorry, W is gone. W is gone, so you're going to have B1, B2, T, no, T is gone. T is gone, so we have E and M, right? And then you can have here W and T on this side. Do you follow what's happening?
Yeah, I'm with you.
So you can now start building a tree diagram. These are the possible options. Right? So when we're looking at the path cost function, right, this boy can go and come back. That's 2x, but they haven't solved the problem effectively. So that's why it was we're considering the distance as a cost function as well in the previous question. All right.
Understand?
Right. If you guys understand, I want you to go and look at the May, October, November question paper and look at the question 1 and tell me you understand.
2021.
We're in 2022, right? 2021, yeah. It should be there in the group under document, but I'll forward it, just refresh it and bring it to the front.
Okay.
Okay. Right.
No
So let's stop there today. Then in the next class, so tomorrow we're likely going to have 2 classes. On Tuesday and on Thursday. So on Tuesday we do uninformed search strategies. If you can just make an attempt to go through the, I'll just make sure it's uploaded. The small videos that will be there, and then we'll do uninformed searches, and then yeah, that's it. After that, we'll do the informed search strategies. We should be able to answer like 90% of assignment 1.
Okay,
Right.
thank you very much.
Okay, awesome.
Colleagues, thank you guys for attending. Enjoy the rest of your evening.
Thank you guys.
Sure.
Cheers. Just good luck.